Hello, well, as Ken said, I'm Linda Brown, and I am a civil engineer who designs buildings and structures. And I would like to discuss with you why you wouldn't want your pet elephant upstairs. I'd like you to start by imagining that we have a box, and I'd like you to suspend this box a metre above the ground. Now, you could choose to hang it from above, or you could choose to support it from underneath. But either way, the first thing you need to know is what is in the box, okay? If there's an elephant in that box, or if it's a box full of polystyrene, it's going to have a significant effect on that supporting structural frame, okay? Our design requirements depend on the load that we apply, all right? Now, if we think about the box itself, we know the density of cardboard, and we can measure its thickness, and we don't expect it to change over time. So we call that our permanent load, or it's our dead load. Okay? But what about the elephant? Do all elephants weigh the same? What if a baby elephant turns up, or a fat elephant? What if there's a pregnant elephant on board? Okay? This load is considerably more variable, right? And we call this load our imposed load, or our live load. Okay? And this is where we as engineers have to start making decisions. If I design that frame for a baby elephant, but then a pregnant elephant was to turn up, I couldn't guarantee that that frame would be safe, okay? And you always got to worry in case there's little baby chickens hanging about, might want to go underneath that elephant. We have to ask ourselves, how safe do we want to be, okay? Every day, structural engineers, like myself, have to make decisions about structural loading. And unfortunately, bad decisions can have terrible consequences. Okay? So if we take our cardboard box and our elephant and convert it into building structures, our cardboard box is our floor slab. We can measure it, we can quantify it, and we don't expect it to change over time. So that's our permanent dead load. Our elephant represents our occupants, just like yourselves in this room. How do I predict whether this room is full of toddlers or this room is full of sumo wrestlers? Okay? How do we design this floor to make sure that it doesn't collapse? Okay? This is our imposed load. It's what we call our live load. And this is where we have to start making critical decisions and start making choices about what occupancy we expect and how we can design for that to be safe. And we do, thankfully, have guidelines and regulations to help us with that. So if you take a typical domestic house, you'd expect your loading to be about 1.5 kilonewtons per metre squared. It looks a bit like that. Your office, school, that's going to be double that. So you can see we're expecting a bit more occupancy. We can assume design for a bit more occupancy. In a building like this, if you were expecting a crowd or a nightclub where you might have a surge of pedestrians for an exit, you can expect a crowd up to 7.5 kilonewtons per metre squared. And you can see here the variety of loads that we would have then for any structure. And you can see that they're all considerably less than an elephant. We could, if we chose to, as structural engineers, design every building and every structure to carry elephants. But we have a responsibility not to waste resources, okay? We wouldn't design your home for a load of 7.5 kilonewtons per metre squared because we don't want to waste the world's resources, okay? We don't want to waste everyone's time and money or materials. So every building that you've ever been in, every structure that you enter, has been designed for a specific occupancy. Okay, and unfortunately, when things go wrong, it's typically when occupancies change and the checks aren't made. And just in case some of us are having a bad day, or you decide to have a big party, we do like to apply a little factor of safety to our imposed loads. Okay, we like to make sure we keep our baby chickens safe. And hopefully now you will understand why, Ken, you cannot take your pet elephant up your stairs. Okay?